So as we have seen before, in this section you can add, in the input summary, you can add all the information, the physical properties that you are having from the lab analysis, like if you have the pour point, the freeze point, the cloud point, and each of these, this is RON and MON. This is for important for gasoline. All of these points are important, and these tests are done. So if you the more information you add, the more strong your assay will be. Okay. After that, the second section is about the pure component. So in the pure component, you can use this tab for this one, and here you have your initial boiling point and mass and final boiling point. You can add in this section, you can add the composition of each one. Okay. So here we have starting from, after that, from C5. So this one from C1 to C4. After C5, we are going to have like a paraffin. So here we are going to add, and this one we have all. I'm looking for C5 paraffins. Okay. So that's how we add a component, pure component. So this is C5 paraffin, which is isobentane or normal pentane. Okay, so I am going to add this one. Here we are dealing again with the volume percent. You can also have a mole percent, like this is the composition. We have the number of moles divided by the total. Here we have the volume divided by the total volume, and here the mass is the same, the mass divided by the total mass. So here we are sticking with the volume percent. So I am having methane, ethane, propane, isobutane, normal butane, isobentane, and normal pentane. So here this is isobutane, so I'm going to add another component which is related to C5 again, but this time instead of iso it will be normal. So at the bottom over here we are looking for C5 paraffin, and it is a normal pentane. Okay, so I'm going to press OK. So we have an iso, and after that a normal. So now by the volume I'm going to enter the value. So this one 0.007%, 0.023, 0.32. This is the majority, so which means here we have propane. 0.24, this is a good value of isobutane. So 1.75, this is larger. 0.65, the values are getting higher, so 2.25. Okay, so this is the volume percent of this pure component. Okay, after that we have still our assay is not characterized. To characterize our assay, after adding all the information that you have in the input assay and the pure component, you can click over here, which is characterize assay. Okay, it will take some time, so give it some time over here. Okay, and it will be turning into green, which means our assay now is characterized. Okay, so we can view our results from the petroleum assay. We have assay number 1. This is our first assay that we are dealing with over here. And we have the input assay. This is our data that we have entered, and this is our conventional results, the printed data after doing the characterization. Okay, so inside this data, what will we find? Okay, the results from the assay calculation. These are the values that we have entered before of our distillation. Here, this is the property table. For each component, we have the composition, the molecular weight, also some physical properties. So we can screen this one. We can check the values by moving this bar over here to check each component and its composition. Before, we have selected our assay to be starting from 36 degrees Celsius, and it is ending at 850. Okay, so this one is our 850. That's why we are dividing our assay. You can decrease these values. This assay is created with a delta T, temperature difference 310, which means each section or each component has a range of 10 degrees Celsius. You can lower this value if you would like. okay, except for this, the first one is only 4 degrees. We have here a composition for water equal to 0, but we have also still some physical properties printed for water, because if at any point we have added a composition for water, the data, the physical properties will be available to do the calculation, okay. After that, from the assay manager here, we have our assay manager available at the top. You can plot your gallery, which will make more sense. Like if I want to check the distillation results, instead of having this, okay, the difference, this one, the distillation result will be available like this. Here I'm having them as a plot, which will make more sense in terms of the results. The more volume we have, the temperature is increasing. We can again go over here at the assay manager, and after that we are going to draw a specific property. Like for the properties over here, we have the density calculated. So for the temperature here, temperature is increasing. We have the density of the cut is higher. So at lower temperature, the density of the cut is low. At high temperature, the cut density is high. This doesn't mean by increasing the temperature, the density is increasing. This is not what this file represents. Here we are having a cut at 200 degrees with a specific density, and we have another cut at 800 degrees with a specific density. The density is different, but it is not dependent in this section on temperature, okay. So the higher the temperature, the higher the density. This is not what this file represents, okay. So I'm going to close this one. Also we have a file here for the viscosity. So if I click on it, I'll have that we have a temperature, we have a cut until maybe 850. The higher the cut temperature, so the higher the cut temperature over here, it will be more viscous, and this does make sense, okay. So instead of having your file or data represented as a table like over here, you can visualize it as a plot. And we can also change the format from here. Like if you want to change the color or the density of the line, it's up to you from these physical properties, okay. So after that, after finishing this section here, we have what we have done. We have done the assay data input, and also we have conventional result printed over here. Sometimes we have a message available over here, like it's a type of warning, like some missing information, or above this there is no input above 90%, because we have the data. You remember, if when we edit the data and the input is say over here, okay, it was until 80%, so the 90% is not presented. So it's just an error or a message. If we have done this one, it will be more reliable results, but this one, the result will not be the best. So that's why the more data you add or you have, the better will be for your assay. One more thing for this assay, if we check the fluid package over here, we will find that we have already an assigned fluid package, basis number 1, and it's pink-robinson, because apparently we are working with hydrocarbons. That's why we add pentane and isobentane, and we already have some hydrocarbons added. That's why we have assigned this one to pink-robinson. So we are going now to save. Don't forget to save your simulation, because it's really important to have this saved. We are going to use it moving forward.